Apparently, the AT&T laptop is very secure, so it doesn't let me, project any company material. Go figure, yeah. I didn't know my boss could do that. So, okay, how do I? Okay, here we go. So I'm Prasanna Ramachandran. I'm a director of the Whitebox design and engineering team at AT&T. I've been in the role for 18 months, so this is my first OCP event. A lot of you may know Duong. He's the lead member of technical staff on my team. He has worked on this project before we even thought about Whiteboxes. So one of the pioneers in the space, and sort of with mixed feelings, I have to say he's retiring later in the year. So this will be his final OCP. He is online if you guys want to ask some questions or give him any comments. So here we want to talk to you guys about our disaggregated distributed cluster, the DDC. So happy to report at this point in time, we have it in production in the core, running the DriveNets NOS, but we also have it on the edge running the Cisco XR NOS. And the beauty of this is it's the one and the same hardware that we use between Acton Edge Core, UFI Space, and HPE. So that's the beauty of this because you could, with supply chain being the way it is, you could reprioritize projects, shift the hardware. That's a great flexibility we get. We also can maintain a common sparring. You don't have to have multiple sparring for different use cases. So that's all well and good. But sort of some of the growing pains that we dealt with is the firmware management. And here we are going to give you all the wisdom, the pain that we went through, and hopefully you guys can learn from us. And because we have come a long way on this. So if you just take the Jericho 2 white box that we have on the edge and the core, there is about like 11 different components. So in the early days when we started doing like firmware upgrades, you would get like 11 unique firmware images or 11 checksum files. We wrote like this integration guideline that would really be like 150 pages. It would like sort of walk you through step by step how to do it. I mean, obviously, we were coming from the Stone Ages, because we were just getting started. We have come a long way. But sort of the challenges that we have here is, so the two NOS that I mentioned, so one of the NOS is based on the mainline Linux, whereas another NOS is of a private or a commercial branch of Linux. So what ends up happening is, so for the black components you see here, like the BMC, the x86 CPU, you can get the source code, source firmware code, and it's easy for the NOS to integrate that. But in some of the red components, you're only able to get the binary of it. And for a mainline, for a private Linux, it's sort of tough to integrate and do it. So sort of you're confronted with two options. One is like, do you do like a perfect integration where the NOS like puts this all together? It sort of increases the burden on the NOS, but our operations, they love it because it's like they can upgrade everything from the NOS. But what also happens is now we are in various stages of certification and deployment. So for example, the peering application is already in production. And now we are in the process of certifying the VPN, the L2 VPN. So, and what happens is, because not all projects are active, they go through a development cycle, they get delivered to production. And after that, it's really, the next feature cycle or the next. So we want to sort of decouple the NOS involvement from the firmware involvement, and that's like a big motivation for us. And for those reasons, while the deep integration of the NOS with the firmware upgrades is something the operations team likes, it sort of becomes, the burden becomes very high on the NOS side. And this sort of explains it, right? So, we now have about 5 different white boxes. And just the Jericho 2 alone, we have about half a dozen use cases using that one box. We have it deployed in our network cloud for the 5G edge cloud. We have it in the edge of the network. We have it in the core of the network. We have it in the aggregation. So about 6 different use cases trying to use the same hardware but we are on different firmware levels and obviously different NOS release levels. So again, the big motivation was to sort of reduce the NOS burden, but sort of give operations the sort of the experience that they are looking for, right? And the one thing when you do this deep integration with the NOS is, the adjustment to the logic, maintaining the prerequisites. That sometimes the NOS people do not know, and sort of you need to pass along that knowledge and wisdom from the ODM team. So I think for all these reasons, we are proposing we would go to a multi-updater based firmware upgrade process. And I'm going to talk about that. But before I do, I'm going to talk about some of our ops requirements. Now, I love our ops team. I came from ops. I did 14 years. I was in the operations team. But their requirements are like a four-factor, right? They want to control the upgrade through the NOS. They want to be in-band because some of most of world cities, we don't have a perfect outer band. So they want to be in-band through the SSH. They want one reload, and they want the upgrade process to complete as quickly as possible. So pretty intense requirements, and I think we've made some strides on it, and I'm going to talk about that. But also one other thing to mention is when we now talk about a DDC, the problem becomes multiplied by 3 because now you have 3 different hardware in the same cluster, right? So now you have to manage all of that. Okay, so let me move on. So the approach that we are proposing is to use a multi-firmware updater, and the owners will be on the ODM to develop this. So basically, it would work this way. So while the NOS is running on the Whitebox, the operator will SSH into the Whitebox, and then he would SCP the multi-updater package, right? So as the NOS is running, you do this, and then you initiate the update command. So now the NOS sort of gets into the staging process. It would copy the packages down to the directories and the partition. It'll set up the metadata files, the log files, the next boot flags, and it would reboot the Whitebox. So now the baton passes from the NOS to the ONI multi-updater, right? So now the Whitebox comes up on the ONI multi-updater, which has been sort of developed by the ODM. So they have the best knowledge of how to sort of meet the prerequisites, how to sequence it. Can these things go in parallel? Can this thing go in a serial way? Do you retry this 2 times, 3 times? So the ODM has like the sort of the best knowledge of it. So the multi-updater runs under the ONI, completes the firmware component upgrades, sets the boot flag back to the NOS, and then you go through one other reboot. And now when you reboot, the NOS picks up back again from the ONI multi-updater. It's going to run the update checks, the version checks. And also the beauty of this is that number 2, we are sort of putting a log together in the ONI partition that sort of, in a verbose way, tells you everything that went on. So if you need to do some troubleshooting, it's still exposed to the NOS. You can like look at the log, you can export the log, and see what went wrong or what went right. And then the operator regains access back into the box. So this is if you are running like a single pizza box, and I'm going to talk to you about how to do this in a DDC construct. Right. Now, as a part of this earlier slide, we are sort of going to talk about these 5 pillars that are sort of now requirements into doing it correctly. So one is the firmware licensing. So we want the ODM to deal with all the component suppliers, right? Which I think they've been doing, but sort of making it more official here. So you deal with Samsung, you deal with Intel, whoever, and you handle all the licensing necessary for the upgrade, for the firmware upgrades, right? And this number 2 is sort of a new big ticket item where we are saying we will get like a metadata file that will be created as part of this multi-updater package. And it has a few things. It says, okay, so for this platform, these are the components that are there, like the 11 components I showed you in that earlier slide. And this is the approved release or the release it should be in. and it says, this is how long it takes to even complete this firmware upgrade for that component. How many retries. So it's sort of like, think of it like a YAML construct that sort of describes all these things, and sort of the multi-updater sort of reads that and executes that map, that mind map that has been put into that YAML. Now, there is going to be a submission on this metadata file from our partners. I'm going to talk about that in a later slide, but basically DriveNets and UFI-Space, Delta, and Acton, they're all jointly coming together to make a submission on the metadata file. I think that's coming up later in the year, maybe in December timeframe. They're still putting the final touches on it. Okay, so that's number 2 here. Number 3 is we asked for a forced upgrade knob. So this is when the PPI gets the box fresh from, like, let's say China. They are sort of prepping it for implementation to going into the field. You need this forced knob to sort of override the versions that is in there, regardless of the version checking. And this is to sort of get it to a factory default and sort of override the firmware that we have upgraded for that particular use case. There is a local log file that like I mentioned, has the verbose log of everything that happened in the multi-updater that is accessible to the NOS after it regains control. And the current image, the known good image, if you have like a redundant BIOS and a BMC, you need to take care of upgrading both the Flash 1 and the Flash 2. I mean, that's sort of straightforward, but that is also a requirement. So sort of we are formalizing all these 5 requirements. And finally, when you go through a DDC, so just remember that a single pizza box I showed you before. Now what's different about here is you have the NCC, which is the server, the HPE server that we have, which is sort of like a NOS brain, right? Because it is the route processor, the control processor. It knows, I mean, you sort of the operator logs into that, so they never lose visibility into the box, even if you're dialed in band. And it sort of orchestrates the copying, the setup, and the firmware upgrades on each of the boxes, the fabric box, the internal switch, so it sort of orchestrates all that, and the operator has visibility into all this process. Okay, and one other thing with the metadata file is, because we do have like a controller that sort of sets up these upgrades and runs it. Now with this metadata file, at every milestone, you're able to report like a streaming log back to the controller, so you always get a good view of where you are in the process. So initially, before we started all this, and obviously there were some optimizations that needed to be done, this whole upgrade process, firmware and NOS combined for a large cluster, which is like a 48 box setup, right? And we don't have all the boxes populated. It's a pay-as-you-go model. So like, let's say you have 24 boxes in it. It used to take us north of 3 hours. And after some of these enhancements have been done, some tweaking has been done, we have cut that process down by half. So it's what used to take 3 hours plus now takes us an hour and a half. So we have definitely put in a lot of optimizations and efficiencies in the last 2-3 years here. All right, and I think this is being contributed to the telco under the DDC project, and we hope that you find this useful and you can take advantage of it. If there's any questions, you can let me know, or you can ask Tuan on the WebEx. Thank you.